fine. Thank you.
Hello again. Back up on the stage again for like the fourth, fifth, sixth time today. So it's a nice place to be. But thanks for coming to this talk. I'll be talking about QtQuick 3D and more specifically, unifying the 2D and 3D worlds of QtQuick. So maybe a quick introduction. I mean, I've introduced myself a few times, but I'm Andy Nichols. I am a software engineer at the Qt company. I work out of Oslo, Norway, in the Norwegian office of the Qt company. I've been there for 11 years, going on 12 years. Trolltech, Nokia, Digia, Qt company, same basic office the whole time I've been there. But yeah, so it's awesome, and I'm happy to be here. So today I want to talk about QtQuick 3D, which of course begs the question, why another 3D solution for Qt? Because we've been here before. I've been here before on this stage talking about another 3D solution. So I want to establish why we need another one. There's so many 3D solutions to choose from. Most obvious choice is Qt 3D. Qt 3D's been in Qt for many years. There was an iteration in Qt 4, reintroduced in Qt 5, and it's still there today. Still works. It is what it is. It's a low-level 3D API for implementing custom renderers. Then last time I was on this stage, I was talking about Qt 3D Studio, which was a contribution from NVIDIA, and we've kind of rolled it into our own thing, and we have an engine around that, shown here on a device. And then, of course, why are we even doing a 3D engine? Like, there's lots of external engines, and you can hook those up, and render to off-screen surfaces and render them inside of, your Qt application, and some customers are doing that. And then, if you're looking in the more broader sense of like 3D offerings in Qt, we have another 3D data visualization module in Qt called Qt Data Visualization, and it has its own renderer. So why do we need another one? Well, that's a good question. And I think part of that actually comes down to the next question, which is there's no single design tool for both 3D or 2D and 3D in Qt. I think this gets more to the heart of things, is that we actually have a lot of solutions there as well. So for example, we have Qt Design Studio. This started as the QML designer, and now it's kind of polished up and turned into what we now call Qt Design Studio. And this is a place where you can visually edit your QtQuick scenes, and then in parallel, like in this case, it's in this picture, it's showing both the 2D preview and the code, and you can see them in line and edit one or the other and see how it changes, as well as dragging, dropping things in there. Like I mentioned before, we have the Qt 3D Studio offering, which is another tool, nothing to do with Qt Design Studio, because you only edit the 3D side of the scene in this tool, and that's not ideal either. Especially when most of the time, if you're doing 3D, you want to combine it with 2D, and I want to see everything in the same scene. We also have, as part of the larger Qt ecosystem, part of the KDEB's Qt 3D offering is this Quesa, and there it's a bit building off of the Qt 3D is a engine for building renderers, and you have to facilitate, how do you actually get content into that tool? So it's pretty cool there that, you take your stuff in your 3D editor, export it out, and do some trickery, and now it's in your Qt 3D scene. But again, it's just for 3D, the 3D side of things. So that's where QtQuick 3D comes in, because the approach with QtQuick 3D was that, how do we take all of the awesome stuff we have with QtQuick right now, with what we call it QtQuick, but it's a 2D or 2.5D rendering API, and how do we turn that into or extend that to also encompass the 3D offering, like say, for example, what we had in 3D Studio, so that I could seamlessly integrate my 3D view and 2D views together. And so, yeah, that's where this actually comes from. That's where we started the thought process of Qt 3D. So here's some guiding principles of what QtQuick 3D actually is. So first thing is that its goal is a unified graphic story of your graphics is QtQuick. Like we have this QtQuick separated in this front end, back end scenario where the front end is QML. You write QML code, and then there's the back end where you have these scene graph nodes, and then those scene graph nodes are then used by the QtQuick renderer to, basically a state for here's what needs to be rendered to the window. So instead of using, each of the other solutions, say, for example, 3D Studio, which has its own front end and back end, or QtQuick or Qt 3D, which also, again, has its own way of doing front end, back end, let's build off of the same patterns established by QtQuick to implement a unified way of doing things. Second is that Qt, as a guiding principle, the Qt APIs are supposed to be intuitive and easy to use. And so I would say that both Qt 3D and Qt 3D Studio suffer from not being as either intuitive or easy to use as we would like, and not in the same way that, say, QtQuick and QML is today. So that's another thing. And then tackling that issue of unified tooling, being able to see both my 2D and 3D content in the same editor and edit them in the same place, so that you do get that, you can do that pixel perfect, like it was designed like this, so this is what it's going to run and look like. And then there's this other tricky thing that comes with, QtQuick has this to a lesser degree, because it's just 2D, like mostly just images. But in 3D, you really have to worry about asset conditioning pipelines. Again, what is the workflow of I'm using Maya, I'm using Blender to create assets, and then I want to pull them into my project, and it needs to run in an efficient way. And say, for example, you need compressed textures, you need the mesh to actually only expose the things that are needed at runtime for real-time rendering, and worrying about that, and making first-class asset conditioning pipelines built into the story from the get-go. Okay, so with that kind of guiding principles established, I want to show you what this API looks like. And many of you were at the keynote this morning and saw the very quick video of yeah, this is the cool things you can do already. But this kind of goes over everything that's in the API right now, because it's actually not that much, to be honest, because you don't need that many things to build up very complex APIs in the same way that with QtQuick, you can take these primitives like item and rectangle and image and create huge hierarchies of things, like more complex items. Well, it's the same thing with 3D. So the only QtQuick item thing that inherits from item, a 2D QtQuick item in QtQuick 3D, is this view 3D class. This is your viewport into a 3D scene, because anytime you want to render a 3D scene, you actually have to project something onto a 2D surface. And so this is your 2D surface, this view 3D. So I have a bit of code here. It actually shows two view 3Ds, and you can see the hierarchy here is that there's a window that encompasses 640 by 480, and then it's split into two items, just as any other QtQuick item. One viewport here, one viewport here, and you have this scene. So referencing two cameras. So for example, this scene right here that represents this previous scene, you have a node structure in the same way that any hierarchical scene in QtQuick is. So the base transform class, a 3D transform spatial node in QtQuick 3D, is this node class. So this is your transform node. It has rotation, transform, those kind of things. And then you put things under that in the scene. So for example, a perspective camera, an orthographic camera, a light, and a model. So for this thing, we have two cameras in the scene. One viewport references the perspective camera, and one viewport references the orthographic camera. And it's actually rendering the same scene from two different perspectives. So on one side, it's this one, and one side is this one, but it's the exact same scene. And you have the option of actually referencing the scene this way. So you can see the scene property is actually referencing the scene root of the node. Another interesting thing, or one of the other ways that you can use View 3D, is that the default property of a View 3D is the scene itself. So, and I'll be showing that in most of the other examples, but you can put just any 3D item under a View 3D, and it'll just, that's your scene, without having to set a scene property. So, yeah, you can see here, this, yeah, so the inline is what it's talking about here. So you can actually do this. Okay, so and a 3D scene is actually built up of 3D scene nodes. So these are going to be it's basically your state and your resources. So things like models, transforms, cameras, lights, and resources, which would be things like textures, because you have to be a little bit more explicit than in QtQuick with textures, but I'll get into that later. So to start with node, again, node is a transform node, and you have a X, Y, and Z property, just like you do in QtQuick item, except the Z property is actually a Z property and not just a stacking order. So it's a real Z. It's a proper transform matrix. And so you can see here that I set the Z value to 0, the Y value to 10. And then because this is QML, you can use any of the QML animation properties on these nodes in the same way that you can anywhere else in QtQuick. So for example, in this very simple scene here where I have a flight helmet, it's very easy to just add a rotation to that scene and move that around. Very easy to kind of visualize or like declaratively declare. Okay. But then, so you have the node, then you also have a camera, because when you're dealing with 3D as opposed to 2D, you actually need to tell the scene, how do I project this 3D thing onto a 2D surface? So this is what these camera nodes do. The current API we have is that there are 4 different cameras, or 4 different types of cameras, all of which are generating a projection matrix. Depending on like how much control you need over your projection matrix, you use one of these. Most of the time, you use either a perspective or a orthographic camera to create your projection of the scene. But there are specialized cases where you would want to have, say, a asymmetrical frustum. So like when you're doing stereoscopic rendering and it's not completely, so you're trying to do like VR, for example. So one eye needs to be slightly skewed over here and one over here. So it's for things like that. But there's special cases. So for example, the frustum camera and the custom camera are about, here's my projection matrix, trust me, I know what I'm doing. We also have these punctual lights, so directional point and area lights. And they also have these convenience classes where you just throw it in the scene and now there's a light. And these will then be used by the material shaders to actually generate that. And so just to give a couple of examples, we have this area light. This is kind of like, a drop light like you'd have in your office, and it's an area of projected light. We also have this directional light. That's like the sun, and it's rotating around the dragon. And then we have the point light, which is, like a light bulb hanging from the ceiling. In this case, it's orbiting around the dragon. And all of these things, like both camera and light, they inherit from the node subclass. So they have all of the properties of nodes. You can transform them in, however you see fit. And another interesting thing about these directional lights, or like a directional light or an area light, is that they kind of have a directional vector baked in. So for example, with the directional light, the default behavior is that light is facing up the z-axis. And if you want to, change the direction of the light, you simply just rotate the node. So set, let's rotate over the x-axis 45 degrees. Okay, now the light's pointing straight down like this. So that's a pretty intuitive way of handling that. Same thing with cameras. Cameras are a bit more special because typically with a camera, it's important that you know the forward direction and the up direction, because that's how you're actually going to render the scene, and you want to skew things like this. But it's the same thing where, like, by default, the camera points up the z-axis and up the y-axis. And then you can just transform, or you could do interesting things like, say, what's this called, the first-person shooter camera thing, where the camera is actually attached to another model, to the head of the model. And now if the cameras just say, oh yeah, it's a child of the head of the model, now when the model's walking around, the camera is always pointing in the direction of the model. So that's just, baked in. In addition to these punctual lights, we also have the image-based lighting, these IMV maps. So basically you pass it in a HDRI image as part of your scene rendering settings, which I'll get into later. And then instead of having like these contrived lights in your scene, it's more realistic. So if we had a HDR capture of this room, that'd be very complex lighting. In the case of this, I actually have the HDR map to the skybox, and you can see things look a lot more realistic when you have realistic reflections of lights in the scene. So you get a lot more interesting reflections on your model, even though the model isn't very, or the model or material aren't very complicated. And you get that kind of for free if you use image-based lighting. To set image-based lighting, we have this scene environment property, and this actually defines how you're going to render the scene. So you have your camera, you have your scene, and then you have your surface you want to render the scene to, but now you have all these settings. So maybe you want to have multi-sampling, and this is kind of global to the scene itself. And so in this case, I set a light probe source, a texture source for that. So it's this HDR file. And then it's going to use that HDR like radial image to actually, for every point in the scene, like where's the light coming from? And then I also have this background mode property that defines like, how do you clear the scene? Like by default, you would just say, hey, clear it to transparent and then blend it with whatever's in the background. Or you could say, hey, clear it to black. Or you could use this skybox and say, oh, then it's just going to use the texture from the light probe source as your skybox entry. And later we'll add a bit more configurability to that, because maybe you don't want to use that light probe as your skybox. As far as like content that you're rendered in the scene, that's what I've been showing so far. Like you need geometry, and like in the same way with QtQuick, you have an item, and then under the hood it has geometry and a material, because then you have like a quad and then something to shade that quad with, like a red rectangle. So it's similar in 3D, where you have geometry, and the one way to do geometry in QtQuick 3D Out is the model component. And the model component takes a source value, which is going to be a mesh file. And these mesh files are actually coming from, they're actually converted from your, say, Maya project into an efficient runtime format that actually is defining the geometry of that model. In addition to defining the geometry, you also need to specify the materials. And so here, I actually show a couple of different cases, one easy and one hard. So for example, that dragon that I showed in the Stanford dragon that I showed in the previous slides, it has a dragon.mesh file that defines all of its geometry, and then it has one material that's defined several times. And that's actually happening because that's a very high polygon model, and it's splitting that model into smaller, the conditioning tool is actually splitting that model into smaller pieces, and then they're all using the same material to generate that. And then in the other case, it's a very simple scene where I'm using one of the built-in primitives. In this case, it's hash sphere, so it's just a ball, and painting it pink with this default material class, which we'll also get into. The important thing here is that these models are actually potentially built up of multiple submeshes. So this mesh file could contain like really, multiple things. So in the case of a car, it could be one mesh, but the tires have different materials because they're black rubber. The car paint is its own material, but it can be one mesh. And in that case, you have this materials, which is an array. And so for each one of those submeshes, you need a material. And that directly maps to draw calls in practice, because, you have to switch the material to say tires are black, Switch to material, okay, car paint. So that's kind of how that works. Which leads us into the next point of materials. And I think this is one of the most interesting things with QtQuick 3D is we have options there. The first is what we call default material. And yeah, that's pretty small, but there's a lot of options. Basically, you can set what is the diffuse color, like what's the base color of this thing, what's the specular map, what's the normal map, like basically all of these different properties. And it has all of these properties, but if you don't use them, they don't cost you anything. Because what's happening under the hood is that, well, we're going to generate you a shader from what you set. So it's dynamically generated based on what you need. So if you want something that's very simple that doesn't take lighting into consideration, you set the lighting mode to no lighting, you set the color, and now it's just a flat shaded sphere. But if you do need, all the bells and whistles, you want to have a displacement shader, which is basically like, oh yeah, there's a height map, and it's using a tessellation shader to generate extra geometry, and it costs a lot, but it'll look really cool. But that's up to you, and you don't actually have to think about writing the shader code yourself because, honestly, most people aren't into that. It's a very involved thing, and really, you want your designers to be tweaking these properties, not your graphics engineers. So this is what this actually does. And this is actually modeled after 3D Studio's material. So if you've used 3D Studio, you'd feel right at home using this material in QML. Or in this case, this is taken directly from the Qt Design Studio. But that being said, we actually have another material that is even easier to use, and this is called the principled material. The principled material is a PBR or metallic roughness workflow style material where every one of the values that you can set is normalized between 0 and 1. So for example, if you want to say, oh yeah, the color is red and it's between 0 and 1 metallic, between 0 and 1 roughness, and so on. And so you can just kind of tweak those values as a designer and hone in on exactly what you want it to look like, and then things will look realistic. The other thing is that you have these same values that you would set 1 to 0. You can also have in texture maps, and these texture maps you can actually generate in your 3D design tool, like again Blender, Maya, 3ds, and also Substance Painter. So there, you can kind of bake all of your materials into one material, so it's a texture. So like over here, where this metallic map is black, it's going to be very plasticky. And over here, where it's 1 or really white, it's going to be very metallic. So then you can have one texture that represents, say, for example, this whole face. Or in this case, it's just the leather part of the face. But you get something that looks more realistic than what you'd have. And what's also good about this principled material, and this is what's, if you use the new Blender 2.8, this is the default material that's there. It's also completely compatible with GLTF2. So there, the default material that they expect is this metallic roughness workflow, and our principled material supports all of those same channels. But then, if you don't want to do things the easy way, we also have what we call the custom material API. And this is where you can write your shader code. If you have to write your shader code, you want to do some crazy stuff, we have a QML API for defining your custom material. And in this case, it's one of the built-in materials that's copper. And so then you can shade your Stanford dragon as if it was some kind of copper. But there, you're basically just defining what are the uniforms. Some of them are, in this case, bool, real, vec3d, and also textures, so the env map, for example. And then at the very bottom, you define your passes of how many passes your shader has, and then each of the, in this case, this copper.frag, so the shader code for what you're actually shading. And so that's pretty powerful, but again, this is the advanced use case. For most scenarios, you'd actually use either the default material or the principled material. And we do actually provide a custom material library that has some pre-built materials that we did, and they're good examples if you're going to create your own custom shaders of how that can be done. And then we also have the texture wrapper. So one of the oddities with QtQuick is that you can't like create resources directly. Like the closest you can get is the image node, and there it kind of expects that it's visualized. Like you can do some trickery with shader effect to use it, but under the hood, really, it's a QSG texture, and like sometimes that's what you really want. And the reason you need a wrapper around this is because it's typically not just an image, it's also about how you interpret that image. So for example, if the UV coordinates are not normalized between 0 and 1, like, do I just clamp it to 0 and 1, or do I multiply it by 10, or do I keep repeating? So you need, and also like, how do I actually want to sample that texture? So you need some kind of wrapper on top of texture to actually say, how do I use this texture? So in this case, I use the scaling of the UVs to, dynamically change the like how I interpret the texture on that brick wall, and like as it's animating, it's changing the how much the bricks are repeated. What's also interesting is that you can use any QtQuick content, like 2D QtQuick content, as a texture source as well. So with that same texture item, instead of using the source property to a URL of an image, you can set any QML component. In this case, I just created a simple welcome item. In this case, it would just be like a rect with some text in the middle, and the color of the rect is animated. But there, it's pretty easy to do that. Okay, so that kind of covers like what's available in the QtQuick 3D API. The next thing is, well, how do I actually get things into QtQuick 3D? Because one of the things I told you was that you need to have a mesh file, and like, where do you get that from? So this is where importing assets comes in, and we have one tool and library for actually doing this. So we have a command line tool called Balsam that lets you condition your assets. And it's basically like a universal tool for converting anything into QML. So for example, if I have that Stanford Dragon OBJ file, OBJ is a like text-based mesh definition format, I can actually call Balsam stanforddragon.obj, and that tool will then output QML. And it'll look exactly what I showed earlier, because that's what it generated. That's where I got it from. So what it'll do is it'll generate you a QML file built up of nodes, textures, models, meshes, and you'll have that. And then you can just use that in your scene in the same way that if you were to create a button component manually, you could just say button. Well, now you can say, oh yeah, I converted the car, import car, or like just put an instantiation of car in your scene. And this tool and library is actually plugin based, so we can extend what's there now, and we have support for many of the common interchange formats like OBJ, FPX, Collada, Blender, and GLTF. And built into this is actually asset conditioning as well, because we can do some introspection into your mesh when you're importing it. So for example, if you have a mesh that, like the Stanford Dragon, where it's just a 3D scan, we can take a look at that and say, oh yeah, these coordinates are the same coordinate. Let's just get rid of that. Or all of these items are using the same material. Let's merge them into one mesh. So we're doing those things so we can actually, even though you're giving us a not very well conditioned model, we can condition it a little bit for you. We can't perform magic. If you give me a movie asset intended for rendering for a movie, and it could take a whole day to render one frame, I obviously won't be able to render that or do anything for you. But if you have a decent model and it has some degenerate coordinates, like, yeah, we'll drop that for you. Same thing with textures. Like, so we're not doing this yet, but this is one of the things that we plan on adding soon is the ability to, oh yeah, there's these textures, they're embedded in the format. Well, let's convert them to these compressed texture formats along with your import, and then give you options with file selectors in your imported component. As I mentioned before, we have support for GLTF2. GLTF2 isn't an interchange format, strictly speaking. It's a runtime format. It's really kind of intended for, WebGL and being able to like download a bundle and then upload that to the GPU and run. We actually treat it as an interchange format. So when we say we support GLTF2, you can't just say GLTF2 is your source. You would convert a GLTF asset or GLTF2 asset or model into QML, and then that would run. And that works really well with our engine because we kind of built things around like that as a format. And GLTF2 is actually a really nice format because many things are well defined, whereas with FPX, like materials could be anything, and there's all this extra metadata added to let you know, oh yeah, it's using this shading model, and it's really complicated. So with GLTF2, we kind of have a nice standard base to work off of. The other nice thing that we built into our asset conditioning tool is portability from 3D Studio. So if you've been using 3D Studio already, it's actually possible to convert those scenes, which are in this like .uia, .uip, XML kind of format, and we can actually take those scenes you've done with 3D Studio and convert them to QML. And then that'll be able to just, oh yeah, import that project, and it'll work like it does in 3D Studio. So it's not like going to do everything that it does. So there's certain animations that don't quite work, but for the most part, like you can take your project and convert it and then do a little bit more work, and then it'll work exactly the same as it did before. Which brings me to my next point, because I don't want 3D Studio to be your design tool, because like I want Design Studio to be your design tool. So we have, oh come on, switch slots. So now we have Design Studio integration, and this is what Thomas and Brooke were showing earlier at the keynote, that along with Design Studio 1.4, you'll actually have support for doing 3D content inside of Qt Design Studio. That way, while it's possible to write all of your stuff in QML as it is the same way in QtQuick, you can also do this. And this is the ideal scenario, because really your designer should be laying out your thing, and they're not going to write QML. So what's also good about this is that we can bake all of this asset conditioning into it. So rather than having you run, say, the Balsam command line tool, which is asking a bit much, you can just drag and drop your model into Design Studio, and it's going to use our asset import library to do all the magic for you. It's going to pop up a dialog box and give you all the options that you would have had in the command line tool, and you can check and import, re-import, do all of those things. And the tooling is actually going to take care of a lot of that asset conditioning stuff for you. Similar situation with compressed textures. The tricky part about compressed textures is there's no universal compressed texture format. You kind of need to cater it to the device you're going to run on, and Design Studio would enable you to do that, to actually say, oh yeah, I need this particular type of compressed texture format because I'm deploying to this device. Okay, and same thing where like you drag and drop your car model into Design Studio, it just shows up as carname.qml, and you drag and drop that in your scene, done. Yeah, so I don't really have to show you this video because this is the same one that we showed earlier. But that just kind of shows that, yeah, it's QML. You just manipulate the item itself. Now I want to talk a little bit about the architecture of like how this actually works. So back to the View 3D itself. Again, this is the only QtQuick item in the scene, and we have options about how you can actually render this. These kind of cover the options. The default mode is actually off-screen rendering, so it renders the 3D scene into a texture, and then you use that as a texture in the scene. So it just shows up as either a item or a texture provider if you're using shader effects or something like that. You also have the overlay underlay scenario we talked about as well, where you can render below your QtQuick scene or above your QtQuick scene, or you can render inline as part of QtQuick. And this is actually using QSG render node under the hood. And each one of these things has their advantages and disadvantages, but this is at least how things are working right now. QtQuick 3D works very much like QtQuick in the sense that there is a front-end back-end separation. The front-end back-end separation is QtQuick. It is the QtQuick render thread where this thing gets rendered. We have a bit of a bridging situation because I can't break very much. There's public API I can't break until Qt 6. But so we have, QtQuick 3D scene graph, or the QtQuick 3D stuff and the QtQuick 3D scene graph stuff. And in this case, they're, instead of being prefixed QSG, they're prefixed QSSG, the extra S being the Qt spatial scene graph. Ooh. Instead of having update paint node, it has update spatial node. This is where the sync point for front end and back end happens. So the front end's telling the back end, here's my state for this frame. And then resources like geometry and textures are, also kind of special in the same way that they're special with QtQuick. And then it's just state. These are all things that, moving towards Qt 6, I can leverage a lot of stuff. I guess I'll get a bit more into that. Yeah, so scene management is, basically syncing the front end content with the back end content. It works exactly like QtQuick. What's kind of messed up in QtQuick is all of the scene management of QtQuick is part of QtQuick window, which is it's always been annoying, to be honest. And there, this is where update spatial node gets called on the QtQuick side through the view 3D. A little bit about the render itself, because right now the spatial render is different than the 2D render because you don't want to screw up the 2D render. You want to have something specialized for doing 3D. So it's a forward renderer, so we're not doing like deferred rendering. The way it works is that you sync the front end with the back end, you prepare the frame, so make sure that all the models are loaded, all the textures are in place and uploaded, and then you render the scene. That's kind of how it works for each time you're doing things. We have this concept of direct rendering versus off-screen rendering, and this causes a lot of trouble, but it's a very big advantage because there's hardware out there, especially in the embedded space, where if you go through an off-screen surface or an FBO at all, you will not hit 60 FPS. You have to render directly to that frame buffer, or you get nothing. It's a very stark difference between 60 FPS, I can do everything, versus, oh yeah, the best I can do is 40 FPS. And this also has implications for, say, tone mapping, where you have to be, the typical way you do tone mapping is you render everything to an off-screen buffer, and then right before you put that on the screen, you map the tone or bring it into sRGB space from linear space and things like that. Well, if you're rendering directly to the screen, now you need to bake that into the actual draw call itself. So you have to put it in the shader and say, oh yeah, before you put that on the screen, make sure you map that to the right color space. There are passes, though. This thing isn't just going directly to the screen always. So for example, we will do, if you have shadows enabled on your light, we have to do a shadow pass so we can get a texture that we can use in the materials later. Similar situation with depth pass. So if you actually do, doing things that require this, then you can do a depth pass. We have special anti-aliasing modes, which are, taking into consideration what's happened in the previous frame. And yeah, there's a lot of complications in addition to, a clear pass where if you want to draw a skybox, that's a whole nother thing of, oh yeah, sample the HDR texture and render that to that, and then render the scene. So yeah, it's not a trivial renderer. It's got a lot of extra steps that can be enabled, and a lot of this actually depends on what you've set in your scene environment object. As far as rendering backends, right now, the notable thing is that this engine does not support OpenGL 2, like the desktop 2, which is the minimum requirement for QtQuick on the desktop. So that can cause some problems, although we do support ES 2.0. So that's kind of a notable thing. So on the desktop, it's OpenGL 3+, OpenGL 4+, and then on embedded and mobile, it's ES2 and ES3+. And depending on which one you have, we can enable nicer things, so to say. So if you have OpenGL 4, we can use tessellation shaders, for example. So it's going to depend on what you set in your materials, what you actually use. And if you do use those things, they just won't work if you're running on ES2, for example. This will change in Qt 6. We talked about or Lars mentioned in the keynote, the Qt rendering hardware interface. Well, all of these, the backend will be the RHI rather than having these OpenGL only backends. If we talk a little bit about the Qt 6 unified scene graph of like what we're doing, what we're thinking about there. Right now, QtQuick 3D has this super class called QtQuick 3D node. The reason for this being is that QtQuick item is inherently a 2.5D item. So X and Y, that's the same. Z is special. Z is the stacking order, and it's normalized between a certain range. And if you start using things outside of that, it doesn't work. Also, QtQuick item has like 80% of the code in QtQuick item is input handling. Crazy, it's nuts. But in 3D, input gets even weirder. So it's a battle for another day. But really, what I would like to see is that these things have a common base class in Qt 6, QQuick item and QQuick 3D node, or the same class. And Z has an actual value because there's no reason why that stacking order, I mean, it would still be the same if it was -300 and 0. It would still be behind it. So that's one of the things we're thinking about there, how we actually accomplish that in a non-breaking way. The next thing is the QSG image, or QSG texture, I think it is actually, and QQuick 3D texture, because they're not the same right now, but they totally should be. The challenge there being that in QQuick, like you're never going to have a one-dimensional or three-dimensional texture, whereas in 3D, you might. And so also there's a lot of magic that goes on with shader effect and shader effect source with regard to this. So I'd like to rectify that because that would make things a lot simpler. SG geometry. So one of the things you might have noticed with that model API is that there wasn't a way to programmatically add your own geometry. Like you had to have a static mesh that was baked ahead of time. Well, we already have a perfectly good class in QtQuick and a perfectly established pattern for doing this with QSG geometry. And it's a bit unfortunate that QSG geometry needs a bit of extra stuff, to deal with, 3D thing, the 3D render. So we needed additional attributes that aren't present in QSG geometry today. But I would like to see this, or I plan on implementing this for Qt 6, so that you can just, create custom geometry the same way you can today with QSG geometry. And then I referenced this a little bit earlier when I talked about the scene manager, but all of this scene functionality of like tracking what's dirty and calling update paint node and all that stuff, that's in QQuick window today. And that might work fine when, the window is always your output. But what about when, this 2D isn't your main target? What if you are dealing with a VR device where there's multiple surfaces or cameras? Like it's not a 2D surface by default. Your 2D content is projected into the scene. Say, think about AR glasses, and I'm trying to project my QtQuick item over there on the wall. Like, I wanted this to be a little bit more generic. So I think I want to separate out the scene manager-like functionality of QQuick window, this dirty tracking stuff, into its own thing outside of QQuick window to support this. And again, input handling is nuts still. That needs to be cleaned up a bit. And then I talked about the rendering hardware interface as well, because we want to take out the basically rendering abstraction that we have now that's OpenGL only and replace it with the rendering hardware interface that Laszlo's been working on. One of the challenges there is actually the shader generation. So I mentioned that, when you create these shaders or like these materials, under the hood, it's creating a shader just for what you're setting, so it's only going to change the properties you have. Well, that gets a little bit tricky when the RHI kind of expects that things should be baked ahead of time, because now you're having to ship a shader compiler just to get this to work. We do have some clever things we can do there, but I think it's going to have to be facilitated by tooling. Like, so for example, to say, these are all the properties I think will change at runtime, and I promise you they won't. I won't do anything else, otherwise I won't have a shader for it. How much more time do I have? Okay, cool. So I just want to talk a little bit about, like, I guess I should have prefaced this with, like, everything I've talked about today is in, at least most of the stuff that I showed you was in 5.4, or will be in 5.14. Like, we've been actively developing it, and it's coming as a tech preview in 5.14, which means that it's under heavy development now. So we're actually, actively adding new features all the time. And so here's a few things that, we're looking into now. I mentioned this a bit, procedural geometry. Right now, everything's static meshes, but, all the interesting use cases, there's procedural geometry. I want to, dynamically be generating the terrain based on the height maps that I'm getting from, say, Mapbox or something, or, popping up the city around me based on that same kind of data. And yeah, so we need to have something there to enable that. So that's something that's being actively worked on right now. The custom material API that I showed you is very like bare bones, and like it's there, you can do it, but again, you have to be an expert to actually use this. But you shouldn't have to be, because there are tools that designers can use to create custom materials, and they should be. And so want to be able to, create such an API that even designers can be doing custom materials themselves, and it'd be toolable. So the other thing that's missing is post-processing effects. So if you want to apply your depth of field shader, you can't yet, because shader effect, which is the QtQuick's way of doing post-processing effects, does not take into consideration the depth buffer at all, mostly because if it did, it's all garbage. It's about stacking order. Like, so when you're rendering a 3D scene, you actually have a useful depth buffer, so you can do cool stuff with it. The downside of post-processing effects is that it guarantees that you're going to have an off-screen surface. So if you are on those embedded devices that don't support this, well, can't do much for you. But that's one of the prices you pay. That's also one of the reasons why it's kind of been deferred, is because there's a high cost to doing post-processing effects. And, basic input is available in QtQuick 3D. You're able to like actually pick an item, like cast a ray into the scene, see what it intersects with, and then do something about it. But that can get quite expensive because, they're not quads like QtQuick. Like input in 2D is so easy compared to 3D. So you need like different layers of like, try this, then try that, and try this, and then you get more and more expensive the deeper you go down. So one of the things we wanted to add was like collision geometry of like, oh yeah, here's a simplified version of this mesh. Test the ray against that, and then, cheap input. So this is this is part of that, and then tooling to like help you create good collision geometry for meshes. But yeah, that is actually all I wanted to show today. There's going to be a lot of things going into QtQuick 3D, so definitely follow us on, look at the Qt blog. We'll be posting updates, and try it out with 5.14.
Are there any questions now for Andy? Yeah.
You talk about rendering on OpenGL. What about WebGL?
So WebGL, so it does work, but it only works with the ES2 backend, and the ES2 backend is pretty limited in what you can actually do in practice, because you lose a lot of the cool features. The challenge there is actually like the level of GL support you actually get from WebGL. So really what you'd want to have is, say, ES3+. And so this is something that me and one of my colleagues have been looking at and hoping to improve, but it's definitely something we're thinking about as a like primary use case.
More questions? Oh, no.
Hi, Andy.
Hey.
Thanks for all the great information. I'm particularly interested in knowing the integration with the 2D QtQuick. So is that only going to be through textures, or in particular, will we be able to mix the camera's system with existing scenes, for example?
So one of the first things that I would like to implement is, and one of the things you may have noticed, is that the only way so far to integrate 2D items into the 3D scene was via texture. But it's not actually that hard to say, oh, well, one of the nodes in my tree actually happens to be a button. And the button being a child of a node, which is a transform node that's projected in 3D space, I have the geometry and the material to render that thing already. So why not just render directly into the scene? And so that's actually something that's actively being developed right now. And I did have a slide for that, but it didn't show up in this presentation. But that's actually something we're working on right now. But that's something we're working on now, because you want to have, you know, your whole, like if you want to do a 3D scene with all your 2D UI in it, it should be possible and it should be efficient without, you know, having to use a texture.
Hi. So I was looking at this, and I know the design studio current situation and how is it presented to designers. Currently, the 3D doesn't look very appetizing in terms of creating a scene, setting your camera, setting your stuff for a designer to use.
You mean like how it's actually done right now in Design Studio?
Yeah.
I mean, I think that at the very least you have to, I think what they've tried to do in Design Studio now is that if you use this View 3D, by default, it's going to assume that there's a camera and a light. Like it's going to generate these things by default. Or at least the idea was that you shouldn't have to know if you're using the design tool that I need a camera and a light to do anything. Because otherwise, if you just throw a model into a View 3D, like you get nothing, it's black. So by default, it's just going to generate you things and then sensible defaults. Because the tooling can do that, whereas QML, like you need to be explicit. Like this is the camera, this is the light, this is this. But in the design tool, you assume nothing. You say, okay, well, you wanted some 3D. Okay, well, here's a whole like framework to build off of. You drag your model in, it should look good by default. I think one of the ways that they could improve that isn't there yet is having an HDR image on the scene by default. That way, like you don't even need a light, and it looks pretty good by default as well. I think that's part of it. I think this is important feedback though for the design studio team. Because again, I'm on the engine team. Yeah, it definitely makes sense. But let them know too.
No more questions. Is that all?
And if you're shy, just feel free to approach me after as well, or anytime.
Yeah,
the next
it was
2
a
days.
long day, and okay, thank you, Andy. And
Yes,
tomorrow
thank you
again.
guys.